So I'm doing problem 1.5.62. It asks, a 25-foot ladder is leaning against a house. If the base of a ladder is pulled away from the house at a rate of 2 feet per second, the top will move down the wall at a rate of r equals 2 over x over the square root of 625 minus x squared feet per second, where x is the distance between the base of the ladder and the house. There are 3 parts to this question. The first asks, find the rate when x is 7 feet. This is just a regular plug and chug. All you have to do is set the equation r equals 2x square root of 625 minus x squared and substitute 7 wherever x is. So 2 times 7 over the square root of 625 minus 49, which equals 14 over the square root of 576, I believe. So I have a calculator here. Just gonna do the simple calculation. 2 times 7 is 14, of course, over the square root of 625 minus 49, which is 24, which is indeed 576. So 14 over 24 is 0.583333. You can't really see it, but it is. So it equals 14 over 24, which equals 7 over 12 feet per second when x is 7 feet. Now, part B of the question asks the same type of question, but it says find the rate when x is 15 feet. So do the same thing. R equals 2x over the square root of 625 minus x squared. Just plug and chug. 2 times 15 feet over the square root of 625 minus 15 squared is 225, which equals 15 squared is 225. The square root of 625 minus 225 is 20. So it is 30 over 20, which equals 3 over 2 feet per second. Now, the third part of the question asks, find the limit of r as x approaches 25 from the left. So, if you graph this equation, you get a graph that looks like this. Obviously, at 25 and negative 25, the graph is going to be undefined because the denominator equals 0. So the thing we can determine is whether or not from it approaches a definite, not even a definite, infinite limit, I guess, since it's an asymptote from one side, i.e. the left, like so. So setting this up, the limit as x approaches 25 from the left of r, which equals the limit of x approaches 25 from the left, which is 2x over the square root of 625 minus x squared. This equals, if you set up a table on your graph, Control T, and you get these numbers. You can see that gives you whole numbers, so you can't really tell whether or not it's going to approach a certain value. But at 25 and over, there the graph is undefined. So for an easy way to find out like 24.9, 24.999, 24.9999, etc., just go to Menu, Table Settings, and actually no, not Table Settings, Menu, Table. It's Table Settings. Go to Independent. Go to Ask. Then press OK. Then it gives you a blank chart with an x and the f of x value. And it will give, if you just write down the x value that you want, it will just give you the f of x value that is needed, or it correlates with that particular x value. So if you plug in 24.9, 24.99, 24.999, you can see that the graph exponentially or very sharply increases as more 9s are added, and it's getting closer and closer to 25. So therefore, based on the graph in the table, the limit of r as x approaches 25 from the left is positive infinity. Also, you can tell that it's going to be positive infinity because it is a vertical asymptote, and at vertical asymptotes it decreases or increases without bound. And in this case, from the left side, it increased without bound, therefore going to positive infinity.